Hey guys, Mr. Bowman here. Our final learning objective, we are learning to calculate the mean and the standard deviation of a random discrete variable. And what I've got there is on the left, I've got a table from our previous video, and that was about the year 9 pop quiz results, and that quiz was out of 10. And what we did in that first video is we calculated the probability of each of the outcomes. And just to refresh us, the probability is always calculated as F over T. There were 20 students in total. That means the probability of 6 would be 2 out of 20, which was 0.1. We'll then do 7 out of 20, 0.15. Sorry, 3 out of 20, and then 7 out of 20, 0.35, 7 out of 20 again, 0.35, and 1 out of 20, 0.05. So that gave us a probability of each of the outcomes. What we're learning to do today is we're trying to calculate the mean of that data, and later on we're going to move on to calculating the standard deviation, which will be a bit more work. So the mean of our data is actually the expected value of that data, and that is the sum of n times p. So n relates to the score in this context, or relates to the value of interest, and p relates to the probability of that happening. And what actually does happen is that sum sign, that little backwards e, that means sum of. So what we need to do is we need to do n1 times p1. So what that means is we need to do the first variable times its probability. We then need to add the second variable times its probability. And we then need to keep that process going. So we'll times the third one times its probability, and we keep going until we've done that for all of the available variables. So let's get into our table. So what we need to do is we'll be doing 6 times 0.1. We're then going to add 7 times 0.15. We're going to add 8 times 0.35. Plus, I'm going to move down for my working, 9 times 0.35. And finally, we're going to add 10 times 0.05. So the key thing I want to note here, the main thing that does go wrong are little calculation errors. So make sure you're really meticulous and really thorough with how you go about calculating this. And don't be afraid. Do use your calculator. Don't get tricky. Don't try and do stuff in your head. You will make silly mistakes. So I've got my calculator here, just as I said. So 6 times 0.1, that comes to 0.6. We're going to add the next one, 7 times 0.15. That's going to become 1.05. We're going to add the next one, 8 times 0.35. Well, that's 2.8. And finally, also not finally, we're going to add 9 times 0.35. That's 3.15. And then finally, 10 times 0.05. And that's 0.5. So those are the expected values of each of those. We're then going to add all of those up. 0.6 plus 1.05 plus 2.8 plus 3.15 plus 0.5. And that comes to 8.1. So on average, our year 9s had a test score of 8.1. And if you think about our data, that does make sense because the middle of the data is somewhere around there in that 8 range. So having an average of 8.1 is not a surprise. So that was the mean, and I'm going to write the standard deviation formula down the bottom, and then I'm going to clear our working up the top, and we'll run through that process a bit more. So the standard deviation is a lot more complicated to calculate, and that formula, there's our symbol for standard deviation, that is equal to the square root of the expected value of x squared. So what we actually need to do to find this number, we need to repeat the process that we've done, except we need to square x. So it'll be 6 squared, 7 squared, 8 squared. And then we're going to subtract the expected value of x, all squared. So that would be the number that we just calculated. So I'm going to pause the video. I'm going to clear the working, and then we're going to get into our question. Okay, we're back. Just going to change to the yellow pen, just to emphasize that. So we just finished up with the mean, and we figured out that the expected value of random discrete variable x was equal to 8.1. And we're going to need that again later for that part of our formula. We now need to do the same process for the expected value of ex, or x squared. And what that formula is, that's the same as what we did. That's the sum of n times, or n squared times p. In other words, n squared times p1, and we need to repeat that process for n2, n3, n4, n5. So we'll get into that. So 6 squared times 0.1 plus 7 squared times 0.15 plus 8 squared times 0.35 plus 9 squared times 0.35, and then finally plus 10 squared times 0.05. We're going to go through just like we did, mathematically calculate that. We do need to be very particular. So 6 times 6 times 0.1, that's going to become 3.6. We're going to do 7 times 7 times 0.15, 7.35. 8 times 8 times 0.35, that's 22.5. 9 times 9 times 0.35, that's 28.35. And then finally, 10 times 10 times 0.05, and that comes to 5. We're then, to find the expected value of x squared, we're then going to sum all of those together. So 3.6 plus 7.35 plus 22.4 plus 28.35 plus 5, that gets us to 66.7. And we've now got the second part that we need for our standard deviation question. So the expected value of x squared, 66.7, and that comes into play over there. So now what I'm going to do is I'm going to rub out our expected value formula, the work that we just did. If you didn't get that down, make sure you pause the video or go back and get that down. And we're going to get into that formula with the two numbers that we have just calculated. Okay, so we are going to switch pen color. We're going to finish up. We'll probably use the white pen for the last one. So we're now wrapping up our standard deviation calculation. So we're looking for the expected value of x squared minus the expected value all squared. So we've got the numbers down there. So that's going to be the square root of 66.7 minus 8.1 squared. We carry on with our working. That's 66.7 minus 65.61. And then when we subtract those, that comes to the square root of 1.09. And we square root that to find our final answer. And that means our standard deviation is 1.0440. And I'm going to stop and round that to 4 decimal points. So very long-winded calculation to get to that number, but it is important to understand that. Hopefully you found the video useful. Now let's pause, let's get into some questions.